Right. Hello everyone, I'm Michael. I'm going to talk a bit about natural language processing videos. So that was like a silly idea I had when we finished the last meetup and I was going home when I was on the train. So I started thinking a lot about videos and how much information is there. So I came up with this problem. Videos are long and you have to watch them every time to find what you're interested in. So if there's a lecture or a tutorial or a movie, you have to watch it through to find where is that interesting bit. Or if you search something on YouTube, someone will have made a small clip of a movie that was a part you like, and you can see it that way. But if someone hasn't done that, then how do you find it? Or what do you do with it? On top of that, in videos there's like an information abundance, right? So there's sound, there's text, there's images, there's time, there can be locations. You can start describing so much more stuff. Where at the moment we kind of apply like machine learning and deep learning, all these amazing algorithms into raw like data as numbers and like rows in the database and all that stuff. But like there's so much we can take out from videos. And this is where it started getting more interesting for me. I don't know if it sounds interesting to you guys. So I started thinking, okay, how can I extract this information? How can I harvest this? So I started thinking, if I can use an algorithm or something that I can identify these things I talked about earlier in the video, I can create a dataset with two columns. So one can be text, and then the other one can be the time frame that this happened. So I could use like, say, something that was mentioned in the movie or in a lecture. There's a lecture that talks about machine learning, it talks about logistic regression. How do I find when this lecturer spoke about this at this particular time without having to go through the whole lecture, How, if it was like a security, how do I find Michael passed through the hall and he didn't steal anything? When did that happen? Do I have to watch 10 hours of a video to find that or not? And, other stuff that can come up for that. And then the second column can be the time frame that this actually happened. So if, for example, we're watching a video and there was speech, we could use some machine learning algorithms to build the first column with the text, and then every time we build that column, then we record the time. And then we have like a place where we can actually go and find where this is in the video. So in my example, I'm using a simple SRT file that is like subtitles for a movie. So just to prove the concept. But then it would be really amazing if I could use other algorithms to actually build that with machine learning rather than just parsing it in a text file. So before I can find that point of interest, I will need to do some pre-processing. And some of the techniques that are used in natural language processing will be removing special characters to simplify the text, make everything lowercase, so we make sure that what we searching is on the right format, and apply stemming. Stemming is a technique where we remove all prepositions and we can simplify the word to its base form. So, for example, if it's if your word has like multiple forms, you will simplify it to its lowest base form. And then that will make it really easy to apply a search algorithm or indexing or anything to find that text. And that's what I'm looking for, finding that text and getting that time to show it. So I found the Levenstein distance, which is a metric that you can use to compare two strings. So if I give an input and say I offer by text or by speech, or even by sound, then I can compare it to another string that is inside my column in my dataset, and then build a metric that says, okay, how likely is one close to another? So what this Levenstein distance does is, it builds a metric. So for every time it needs to substitute a string to make it the same, or insert a new character that is missing from the text we're searching for, and all the rest, and this metric will become higher and higher. So all we need in the end is like which one is the metric with the lowest, right? It's not the best solution. I was just trying to build something really simple and just prove if actually it will be worth to doing it at all. And yeah, so after we apply, then we can get the column where the time frame will be, and then we can use the time frame to find actual contributors. So we can see like these are our simplified text, which is the first one. Then this will be the time frame. This is in seconds. So when is this happening in the video? And then the last one is the similarity score, which was built by the latest time distance. So I just appended that similarity list into my dataset to have 3 columns. And then basically say, okay, when I found this, just give me the time frame and show me that point. So what I did is I built a simple prototype for this. If I can use my computer. Anyone see my screen? Yeah, for some reason I don't know why. Is it looking any good? Yeah. So I just made a simple search, and I can say, yeah.
Plus.
Yeah, keep going.
Yeah, that's great.
Yeah, and this is like a solution. So I parsed the SRT file subtitles of the movie Space Odyssey 2001, and then I built these columns, and then I'm searching for this text to say, okay, where does the guy talks to HAL and say, okay, how where the page goes. But yeah, that's it. It was only a small thing.